Definition 5.2 is going to define for us mathematically what it means to be a composition. So there's some notation involved in this. It says, given two functions f and g, the composite function f composed with g. So I want to take a moment to clarify what's going on here with this notation. You all should be very familiar with symbols like this or symbols like that. And the purpose of these symbols is to represent an operation. You recognize the plus symbol as a addition operation. The radical symbol there is the square root operation. So now with the composition, we want to think of it as an operation and it needs its own symbol. So we use a little open circle here to represent the composition. So f composed with g is how we're to interpret that, f composed with g. It can also be called the composition of f with g, and it is defined by embedded function notation. So every time you see f composed with g of x, that is the function notation for f of g of x. So you're going to be taking the result from g and you're going to be using it as the starting value for f. So from an arrow map perspective, it would look something a little bit like this. I have a first set and a second set. So the first set is where I'm going to pick values for g. So the first set is definitely going to be the domain of g. So I'm going to pick some x value from here, and then that's going to map over here into the second set. And the value that it maps to is called g of x. And then I'm going to take that result and I'm going to immediately apply it to another map. I'm going to immediately apply it to f. And when I apply it to f, it's then going to give me what we call f of g of x. So there's two functions going on here. There's g, which is going to be outlined with these first two sets. And then there's f, which is going to start with whatever g ended with, and then it's going to go to its own ending place. And so this is the arrow map of what it looks like to put these two functions together, and they get put together. The end of one becomes the beginning of the other. So that's what we'll be doing with the equations and the individual function values. But a function also has to be defined with a domain. So when you look at this picture, and if you think about trying to start here at the beginning and then eventually work your way all the way over here to the end, you have to start with this very first set. Well, that very first set is the domain of g. So the domain for your composition is going to be very similar to the domain of g. So notice that we don't have to really do much with the domain of f, except we have to make sure that whatever g of x we calculate is going to be allowed to be mapped over into f, using f. So there's that one extra consideration there at the end, that g of x has to be a part of the domain for f. So we'll see some examples of how to be able to work through all of that, but I want you to be upfront and aware that the way we calculate the domain for the composition is not going to be the same as the way that we calculate it for f plus g, f minus g, f times g, and even f divided by g, which is its own calculation as well.